Hello, my name is Camila Barang and I am part of Challenge 2014. This is assignment number 6, video submission number 1. So for this assignment, we need to find the volume of a specific region inside between two different equations. So for this equation, so our question says to find the volume of rotate the region between bounded by x equals y minus 2 squared, the x-axis, and the y-axis about the x-axis. So in graphical terms, what this means is that we're going to be left with an equation that looks similarly like this. Okay? So it's going to be, we need to find the volume of this region. Because what we're looking for is for the sideways, this here, since x equals y is the sideways parabola of this equation, and so it is then bounded by these regions. So how do we determine which regions are the ones that it's bounded by? Well, first what we need to do, it's the same thing as its limits, is find the c and the d, which according to the shell equation are going to be the limits for that we're going to substitute later into this equation to find the volume. So first, we know that, so in the equation it tells us that it is bounded by the x and the y-axis. So the y-axis is y equals 0, so c, which is going to be our least value, is going to equal 0. And then we have then we're going to substitute x equals y minus 2 squared. We're going to substitute x as 0. So we substitute as for the value of d, that x equals 0, and so we get that y equals 2. And so this y, we're going to put it in the y, so we have 2, and that's why it's bounded by here. So these are the limits. Okay, so now that we have this settled down, we can finally substitute into the equation. So what we're going to do is that we're going to place 2p times the inverse of 0 to 2, y minus 2 times y, d of y squared. Okay, so this is what we did by substituting this part of the equation. And now we're going to integrate. So, well, first we need to expand this equation and then we can integrate. So this is going to expand into, well, 2p, 0 tends to 2, y squared minus 4y plus 4. Okay? So, and then we need to multiply this by y, so, which is finally going to leave us with 2 pi as 0 tends to 2, y cubed minus 4y squared plus 4y, d of y. Okay, so now we need to find the integrate of this equation. And so it's going to be according to x and plus 1 and plus 1. We can find the integrates because for the exponent values property. So we're going to be left with, so 2 pi times y fourth over fourth minus y third over 3 plus y squared 2, because we can eliminate with the 4. And so, yeah. And then we're going to substitute 0 and 2. So, once we're able to substitute these values into the equation, we are left with 16 over 4 minus 32 over 3 plus 8. That's going to give us 12 minus 32 plus 24 over 3, which is, and this is all going to be times 2 pi. which is finally going to give us a value of 8 pi over 3. So this is the value of the volume in this set of equations. Thank you for listening, and I hope that you can understand that the shell mesh method was used in order to determine the volume of this shaded region, which was explained by the equation, because we wanted it to be about the x-axis, so it rotated here in the x-axis, our shell, like when you're doing a shell. And so yeah, so this is your answer. Thank you. Goodbye.